Now, by way of an extended example of what we've just done, I want to introduce to you what we call the standard form of the equation of a line. And that standard form is a form of y equals mx plus b, where every linear line or linear equation can fall in that format. So for example, y equals 3x, well, that equals y equals 3x plus 0. There's no b value on that one. So let's give a b value, and let's look at something like maybe y equals 3x minus 2. How would that graph look? All right, let's begin with an xy table. Again, let's choose 5 values, -2, 1, 0, 1, and 2. I'm going to stay away from 10 on this one just because it got a little large there. So the equation I'm doing was y equals 3x minus 2. So if I input a -2 into that equation for x, and we evaluate it, what's my y value? My y value will be 3 times -2 is -6. -6 minus 2 is a -8. If I put a -1 in there, 3 times the -1 is -3. -3 minus 2 is a -5. 0 makes it a -2. And I'll let you work ahead of me right now. If I input a 1, and if I input a 2, from that point plotting an XY table, I'm able to develop some coordinate points. You might be able to visually see those coordinate points from the XY table. For now, I'll still kind of write them out in their official coordinate pair. Five points is more than enough points to draw a line. 2 points is all you need to draw a line, but I have several points just to make sure as my algebra skills are getting better, I tend to make mistakes. And so I want to make sure that I have a couple of points to corroborate the other points I have. So that's why I do more than 2 points, because one of those points could be wrong, and then I'm searching in the wrong place. So let's draw these points. The first one is -2 and -8. So backwards 2 and down 8. Backwards 1 and down 5. Backwards 0 and down 2. Over 1 and up 1. And then over 2 and up 4. Those look like I did a good job. They all appear they would be linear. And then if I were to graph it, it looks like I get a line that's parallel to the original line that I've done, but it looks like for every point, the corresponding point is shifted down 2 units. 0, 0 in the blue is now 0 and -2 in the orange. -1 and -3 is now -1 and -5. So it looks like my y value was shifted down 2 units as compared to my original one. Interesting. 2 units down, shifted 2 units down, a -2. So maybe we can say that this value of b and our y equals mx plus b is our shifter. It might take the graph that's produced by the first part, then shift it up or down so many units depending on what that value is. So my value is a -2. I have my graph y equals 3x, but it's just shifted down 2 units. If that was a positive value, then I would shift the graph up a positive value of whatever many units that would be. So those are some of the insights that I'm hoping you're starting to be able to see and grapple with, because if you're able to hang on to those, you're going to see a whole world start to unfold very quickly as we start to learn how to graph some different linear equations.